Hello, today we are looking at the emission spectrum that forms a hydrogen atom. The fact is that emission is a process when electrons from the upper energy levels can move inward. Accordingly, this movement is accompanied with energy absorption because moving inwards costs energy. In this case, the emission spectrum of hydrogen is accompanied by the formation of a series of lines, and these lines are called a series of such lines. They are named after the scientists who discovered such lines for the hydrogen atom. The first line is called the Lyman line, and it is detected in the ultraviolet spectrum. At the same time, the level to which the electron transitions from the higher level is the first energy level. So, from which levels then can an electron transition to this first level? In other words, N in this case is the level to which the electrons transition from higher energy levels. N is the energy level to which the electron transitions, and M represents the levels from which this kind of transition is possible. So this transition can happen from the second, third, fourth, fifth, and so on energy levels. The next line is called the Balmer line. It's seen in the visible spectrum, emission spectrum, which you get. But then the electron is and goes from the upper levels to the second energy level. From what levels will such a transition be allowed? It would be level 3, level 4, 5th, and so on. Then the Paschen line, which is observed in the infrared. Then the level to which the electron descends from the upper levels will be the third energy level. And from which energy levels is such a transition possible? In this case, it will occur from the fourth energy level, the fifth, the sixth, and so on. Afterwards, we have the bracket line, which is similarly detected in infrared radiation. So, to which level can an electron descend from an upper level? This would be the fourth energy level. And from which levels is a transition possible in this particular case? It would occur from the 5th, 6th, 7th levels, and so forth. The last line in this series is the Pfund line, which is observed in the infrared radiation spectrum. In this instance, the level to which the electron descends will be the 5th, and from which energy level can a transition occur to the 5th? From the 6th, 7th, and so on. It's quite easy to observe a consistent pattern, which shows, for instance, that a transition to the first energy level is possible starting from the second one. This means the difference is always just 1 unit. Therefore, these are the levels from which downward transitions are possible. In this case, it's from the second, third levels, and so on. The difference between the numbers of these levels is 1. The first energy level is the lowest, and then the first energy level from which a transition is possible would logically be the second level. As such, for the second level, the nearest possible transition would be from the third level, and so forth. This consistent pattern does not change. Therefore, it follows that electrons, which are present in an atom, in this particular case the hydrogen atom, may not only be located near the nucleus on the first energy level, as we might initially expect, but also the hydrogen atom, however, contains electrons that are capable of moving far away to the outermost energy levels, such as the 7th energy level or the 6th energy level. These electrons can make transitions from these higher levels downward, meaning they can move to the lower, more internal energy levels. During this process, emission takes place, and the resulting type of spectrum is referred to as an emission spectrum. The spectrum of hydrogen holds a particularly crucial role when it comes to examining other chemical elements, because by knowing from which energy levels such transitions are both possible and allowed, we are able to calculate these emission spectra, for example, for other elements such as sodium, potassium, sulfur, and others. These kinds of spectra are catalogued in the form of detailed references, which we can also analyze together. However, the most important role is undoubtedly played by the emission spectrum of the hydrogen atom itself, which introduces the concept of specific series of corresponding spectral lines, which we must memorize. These lines follow a distinct pattern and are linked to the numbers of the energy levels that we have been discussing in the context of the atomic structure of any chemical element. This pattern remains consistent across all elements. That concludes today's lesson. Goodbye for now.